guys. So today in the second session we are mainly going to focus our learning on units and measurements. So what are these units? What are the measurements? What we need to measure? So let us see first what are units mainly. So when I say units, what comes to your mind? Maybe think for a second. You might say the units of meter, hour, seconds, and so the list goes on, which usually comes to your mind. So what is this meter? What is an hour? What is a second? What are these units exactly? So when we want to know what exactly these units are, this is a method or a reference we use to measure something in terms of a unit. So for example, when you just write a number 10, what does that mean? Nothing. It is just a number 10. But if you write a unit 10 meters, what does this mean? So 10 meters is something, as you all know, meters. So what meters is something which represents length. So 10 meters is something which says it is 10 meters long, or the cloth is 10 meters long, or the building is 10 meters away. So this is something used to measure the length or the distance. So when a number is accompanied by an unit, you get the value of something you need to define. Similarly, when I just replace meters with seconds, so you know seconds is a unit of time. So when I say 10 seconds, then you understand that I am trying to say about how long something takes, what is the duration of something. So once a unit accompanies a number, you know what exactly you are defining or what you are trying to focus on. So this is the main necessary of units. But I think you all are well aware. When I come to length, let us say, for example, length, the units of length can be meter, it can be centimeter, it can be inches, it can be feet. So these are different units in which we express the length. Every unit has its own definitions of the length. So if I say what is a meter, what is a centimeter, when you speak about these two, I think you are well aware of meter and centimeters, because it is the unit you would come across using your measurement scale. So it's in a measurement scale, so if this is a measurement scale, for example, so I know you would have observed the larger lines and the smaller lines, a little larger line and a smaller line. And they would also mention here what are those units, or the inches or centimeters. So on one side of a unit scale, usually you can see centimeters and millimeter. On the other side is usually inches. So these are the units you usually come across in your daily life. So what is the difference between a centimeter and a millimeter, for example? So 10 millimeter is equal to 1 centimeter. I hope you understand. 10 millimeter is equal to 1 centimeter. So the smaller lines in the unit scale are of millimeter and the larger lines at specific intervals are of centimeter. So this is just an example of how there can be different units for a length, and each units can be converted from one form to the other. For example, here I have shown the basic conversion from the millimeter to the centimeter. So this is the main example why we require units, how the different units can be converted into different forms. So one thing which might come to your mind, does everyone represent a unit in millimeter or in meter or centimeter? How would you know in which units should we represent? So let me say, there are mainly 3 different methodologies which were actually used for the measurements. First is a CGS system. So what is the CGS system? In this system, the C stands for centimeter, G stands for grams, and S stands for seconds. So what does this mean? So in the CGS method, the length is usually expressed or measured in centimeters, while the weight is expressed in grams and the time in seconds. So when you are using a CGS system, you know you need to have the units always in centimeters, grams and seconds. The second system is, so first is, I hope you remember, I'll write the first system here, CGS, centimeter, gram and second, the length, weight and the time. So the second system is FPS. So I hope you can now know what is this. It is same as the CGS system, seconds. But what is this F? Here F is measured in feet. How many feet? The length is measured in feet and expressed in feet. And P, the weight, is usually expressed in pounds. In CGS it was centimeter, gram and second, whereas in FPS it is feet, pounds and seconds. So second is FPS. And the third system is MKS. So what is this MKS? M is meters, so the length here is measured in terms of meters. K is kilograms, so the weight of something is measured in terms of kilograms. And S is as usual seconds. So MKS is meter, kilogram and second. So I'll write all the three together once. First is CGS, second FPS, and the third is the MKS. So once again I'll repeat. So C centimeter, G for gram, S for second. In FPS, F is foots, P for pound, S for seconds. And for third, MKS, meter, kilogram and second. So one thing for you see in common is time is measured always in terms of seconds, in all the three systems. So again, I know you might get it doubt. There are three different ways you can express, and yes, you can you would be able to convert from one system to other system. Like earlier I showed 10 millimeter is equal to 1 centimeter. So in this, this is one example. So millimeter to centimeter conversion is available. Similarly, centimeter to foot, foot to meter, meter to centimeter, all the conversions are available. That's true. But how would you know? In which case, in which system would you follow? Why there are three different systems? So let me come to that. As I said, there are three systems in which we express the units or the quantities. There was also a confusion between these scientists. It was in 1998, NASA had launched an orbiter to Mars. It was some $330 million project. They wanted to study the weather on the Mars. What is the weather conditions on the Mars by the orbiter orbiting around the Mars. But what happened then? Actually the orbiter crashed into the Mars surface. So what was the reason for the failure? So the failure for this project was mainly because the software which gave signals or information to the orbiter, like how much distance it has traveled, how much distance it has to travel before it goes around or before it enters into the atmosphere, at which angle, at which force. So everything is controlled by the software on the Earth, and the orbiter simply follows the signals it receives from the software. So what happened was, the software was giving measurements in terms of feet and pounds. Feet, not feet, foot and pounds. But whereas the orbiter was taking the measurements in meters and kilograms. This was the mismatch which was created, which caused the $330 million project to crash. So that is when the scientists came up that we should have one standard method of measurements throughout the world, so that such confusions would be avoided in future. That is when SI units of measurements came into existence. So this is called as standard international units for measurements. Under SI units, the length is usually measured in meters let us say the mass is always measured in kilograms, and time is always measured in seconds. So for the SI units, it is usually MKS system, which is considered as the standard international unit systems. So length is measured in meters, mass in kilograms. Mass you can also say weight, and mass anything. For now both you can consider. I know the definitions of mass and weight are different, but the units for measurement is for both would be in kilograms, and for time it is usually in seconds. Okay, and these units also, these are the names of the units we measure. So each time you want to write some 10 meters, you cannot write 10 meters or 10 kilograms. So it takes a lot of effort. So each of these units have a symbols. So meters is expressed in small m, kilograms in small k and small g, kg, and seconds in terms of a small letter s. So instead of writing 10 meters, 10 kilometers, you can easily write it as 10 meters, 10 kg or 10 seconds, the length, the weight and the time. So this is the basic units let us say. But actually, so here I have gave you an overview of 3 units used in the SI, 3 units of SI units. So are there only these 3 units? No, SI units also have other 4 basic units which I don't want to tell you at the beginning. So let me explain you first about variations of length and other measurements, how the measurements, and like that let us go one by one. I don't want to confuse you with the other 4 units at present. So you can say there are 7 base units in this standard format. Why I mention here as base units is there might be different factors which would come up later as you further go into different concepts of physics, but those units would be a combination of the units which would come under this 7. So those are called the basic units or the base units. Okay, and also there are 2 other units or form of measurement we use in this SI system. Let me just give you an overview about that measurement. So let us say there is a point here, point P. From point P, you have a line going to point Q and point R. So just imagine this to be a cone or a part of a circle, let us say, for better understanding. So you have a circle here. This is just one part of the circle. So this is the center of the circle P, and these are the radii. Let me write it as R of the circle. There are 2 different random radii, and you cut away the remaining part of the circle. So what remains with you is this. So here the angle between these two radii, let us say it as theta. And as you all know, the angle subtended the theta which subtends this curved line is usually called as arc. Let us say this arc length to be ds. So this is the angle between the two radii of the circle. The ds is the length of the arc, and this is the angle between the two radii. So there is a definition of measurement, like what is this angle subtended. So here you have ds. So the angle subtended here, theta, is given by ds by r. So the angle of the two radii, if you do not have a protractor, you just have a meter scale or something in which you can measure meters, then you can say this is the method you can use. So you can measure what is the radii r, and you can measure what is the length of this arc ds. So theta is equal to ds by r gives you the angle. It's angle between the radii, and so this angle is denoted by a unit called radian. So this is the unit, and the symbol for radians is RAD, radians. This is the full name of this theta unit, and this is the symbol. This is the unit name, and this is the symbol for radians. So I'll repeat you how the measurement is done. You have a complete circle. You just draw two radii at a random angle, and then cut away the remaining part. But now you are not aware what is the angle between the two radii. So what you do, you have this formula. You measure the length subtended by the theta, the length of the arc. You divide that by the radii of the circle. So you then know the angle between the two radii, and this angle is expressed in terms of this theta. This theta is nothing but radians. This are measurement, and the symbol is RAD, rad. So here it was just on a paper what we saw this measurement. So a similar measurement can be done on a solid. So here it was just a circle. On this was on planar angle, let us say. That was a planar angle theta. So it was on a 2D plane which we saw. But what if you have a 3D angle? So this itself is a plane, let us say, and then you have an angle here. So it is something I can say of a solid. So here you can imagine yourself with an ice cream cone. Just you have kept the ice cream cone sideways, and it is an ice cream cone which might have a which has a lid closed, which is closed here with the surface area dA, and here as usual you have the length r, and there might be an angle on the cone. What is the angle at the peak of the cone? That is called a solid angle, because here you are dealing with an 3D object. So here it is called as solid angle. The previous was just a planar angle, but this was this is a solid angle. So this solid angle D omega. So this symbol, please remember, this is called omega. The angle D omega is measured by dividing the surface area the angle subtends. So what is the surface area about this angle DA divided by radius, but this time the radius is squared. So previously, okay, let me write this as solid angle d omega, which is equal to dA, that is the surface area divided by square of the radius, and this is expressed in steradians. The unit of d omega is steradians and the symbol is ST. And similarly, planar angle. For the planar angle, it is just between two lines and an arc, theta, r and ds. So theta, which is equal to ds by r. This is in terms, theta is defined in radians, symbol RAD, rad. So this is a planar angle. Here it is the radii, it is just divided by radii, whereas this for the area and the solid angle, it will be divided by radius squared. So the units for solid angle would be steradians and for planar angle it would be radians. Hope this is clear for you guys. Because based on this planar angle and these solid angles, we are going to see different measurements, how it is used, what are the applications or uses of these angles in our lives. So, as I said earlier, in your scales, the measurement scales you use, you would be able to measure the distances up to distances of 10 to the power 2, let us say up to a meter. So you have from millimeters, that is 10 to the power minus 3 to 10 square, that is 100 meters too. I think you can use the long tapes, measuring tapes and different scales you have for measuring this range of units. But this is not the only range we would come across in our world. You have the units smaller than 10 to the power minus 3 and also larger than 10 to the power 2. So, first let us see how the units larger than this measured. Let us say very larger than some 100 meters. For example, to understand, I want to give you an overview how the distances from Earth to a distant star measured. You cannot take a measuring tape and measure the distance from the Earth to the star. But how is it measured? You come across the different distances of how far the planets or how far the stars are from the Earth. But how is this measured? So, to understand the basic measurements, how this is done, let me give you an easy example which you might have observed, but you would have never thought about it. Why is it? What is it happening? So, I am holding a chalk here. So, when you see the chalk with both your eyes open, maybe the chalk appears to be here. You can try it. And so, then you try to close your left eye And if you see the chalk with just a right eye, the chalk might appear somewhere here. This is with only right eye. If you close the right eye and with left eye open, the chalk might appear somewhere here. So, what is happening? What is this difference in the positions of the chalk with different eyes open, both the eyes open, one eye closed? What is this difference? This difference, what we experience, is called parallax. So, what is the reason for this difference? This is because our both eyes have a certain distance between them. So, this distance between the eyes is the distance you would experience here. I hope you understand. This is the different positions of the chalk you see with each of your eye open actually gives you the difference in the distance between both of your eyes. So with left eye open, you see exactly the chalk straight to the left eye. With right eye open, you see the chalk exactly to straight with your right eye. So this distance is nothing but the distance between two of your eyes. So why I am saying you this? When I wanted to explain you how to measure the distance from Earth to stars. So I wanted to say this because this is the method, the parallax method, this concept we use to measure the distance from Earth to different stars. How is that? So let me say even another example different than this. So let us say you have a tree here and these are roughly a mountain peaks away, a little larger distance away compared to T. So here you have a person at this position, let us say A. He would see the tree. Along with the tree, he would observe different background. So he is seeing tree with respect to a background. So if I draw a straight line through the tree to the background, this is how it would be. So he might be seeing the sky which is here at the background. Similarly, now let me say there is another person here, B. He is just let us say some 10 meters away. He has not moved forward or he has not moved backward, but he has just moved to his right by 10 meters. And now again you would see the tree, this person, and this time, so here you would see the background here, the mountain here. So these are the two different lines, the line of sight. And here you see there is a spot at which near the tree where the two lines of sights intersect. So for the person B, let me just draw a straight line and the dotted lines for the person A. So this is the line of sight for person B and this for the person A. So this lines are extended with respect to the mountains in the background of the tree. And so here you can see some angle theta between these two lines of sight. So I guess you're getting an idea where this is leading to. So here if you say the unknown distance from the person A to the tree B, D, and since this person has just moved in one direction, that is without moving forward or backward, he has just moved to his right. So this distance remaining same as D. So here you are getting an idea this is a planar angle, let us say theta. So now you can measure this distance d, because you know the distance here and you know the angle subtended. So this is the concept we use for measuring the distance for the stars too. So here I can say, so earlier I had defined theta, which is equal to, in the planar angle, if you remember, theta is equal to, since you can say this is a small distance 10 meter, it is also the length of the arc, or the you can approximate this straight line to be the length of the arc. So 10 meter divided by this unknown d. This is the planar angle formula. So d is nothing but 10 meter by theta radian. So with this you would get to know what is the distance from the person A to the tree, and say since it the B is also standing from the same distance, it is the same distance from the person B to the tree. Hope you understand. So this person's sight would be with respect to the background, and this person's line of sight with the background intersects at an angle at the tree. Tree is, we are interested in measuring the distance of the tree. So at that point you have the angle theta, which can be measured, using which you calculate the distance d. With this concept, the distances of the stars far away are measured. So how is that? So now instead of a tree, let us say you have a star S, whose distance from the earth you need to measure. And there are plenty of stars and other heavenly bodies in the background. So if you are measuring a star at a particular distance, you try to keep a background. You try to measure it with respect to your background stars. Or so with respect to some background star. That is, these background stars doesn't vary soon with time. That is because they are at a very large distances from the earth, so it takes years for that to change the position. So it is more or less a constant. They are at more or less constant position. And so yeah, you can say you have an observatory at A, and you measure the position of this star with respect to a background stars, and you have an observatory at B, and again now you measure this star with respect to a background stars here. So again you can have this theta, the parallax angle, and the distance between the observatories you can calculate on the earth. So let us say d, and this distance b, let it be the capital D. So as I said earlier, the planar formula was d theta by the length of the arc, here the length between distance between the observatories, divided by the length of the radian, that is the distance from the star. So theta can be measured, d can be measured, so the capital D would be d by theta. So this is the method we use to measure. In some cases, instead of two different observatories, the same observatories can do the measurement. How is that? You do not have two observatories. But you know, if this is the sun and the earth is, sorry for the orbit shape, so earth is rotating in an elliptical orbit. You have the earth at position A today. So you would measure you would view the star with respect to the background from A, and then when the earth is at the position B, with the same observatory, you would again measure the position of the star with respect to the background. And you know what is the distance from the earth to the sun. So based on that distance, the diameter of the orbit of the earth, you can calculate the distance, capital D. So this is the basic method we use to measure the distance of the stars. So here I just said about the distance. So you would also come across saying the planets are this large in radius, this large in diameter. How is this radius and diameters measured is from the similar measurements what I had explained. But here the angle theta would now be the angle subtended by the angular distance, let us say alpha. So this is the angular distance the planet subtends in the sky, and the measurements would be similar as before. Alpha, which is nothing but the length of the arc by the distance d, so which implies d is nothing but the distance small d, the arc distance divided by the angle it subtends. So these are the methods we use in measuring the very large distances. So let me just revise you the topics we learned today. So mainly we learned about different unit systems, CGS, FPS and MKS, centimeter, gram, second, foot, pound, second, meter, kilogram and second. And then we have the standard unit, international units, which is used by the scientists around the earth. So this is nothing but the MKS system it usually uses. And this has 7 base units. Of which the 3 base of the meter, kilogram and the seconds. And the 4 base units we would be learning in next video sessions. So adding to those base units, we have the planar angle theta, which is equal to the angle of the length of the arc divided by the distance of the radii actually from the point, which is expressed in radians, whose symbol is rad, and the solid angle d omega, which would be the surface area by the square of the radius, which is expressed in steradians, ST. And using this basic formula, we measure the large distances from the earth to the stars. So these were the main concepts of today's class. So in the next sessions, we will further learn about how the smaller distances will be measured, And also after that, in further video sessions, we would learn about the other remaining base units of the SI concept. And then also we would try to solve different problems regarding these solutions, different solutions we can try to get by using all these 7 base units of the SI standards. Thank you guys. Any doubts and clarifications, please comment in the comment box. Thank you.